Okay, we're going to have a look at what happens to the circumference and to the area when we do something simple like doubling the diameter of a circle. Here we have a circle that's 8 centimeters in diameter, and here we have a circle that has double the diameter, it's 16 centimeters. So what we can say about this circle is that the diameter is 8 centimeters, the radius is half the diameter, which is 4 centimeters. The diameter of this circle, it's double the radius, so it can be thought of as being 2 times 8, which we know is 16. The radius is double the radius of this circle, 2 times 4, which we know is 8. What effect does that have on circumference and perimeter? Well, the circumference of a circle is always calculated by pi times the diameter. So for circle 1, the circumference of circle 1 would be pi times 8, which is, we're approximating pi to 3 in this question, just to give us an approximate value of the circumference. So we'd get 3 times 8, which is 24 centimeters. So the circumference of circle 1 is 24 centimeters. The circumference of circle 2 is pi times the diameter of circle 2, which, let's keep it as 2 times 8 here. So we actually see what's happening with this double dimension here, the multiply by 2. Well, that would be the same as 8 pi times 2. We know that 8 pi is 24 centimeters, so we'd have double that. 8 pi is 24. So we would be doubling the 24 to get the circumference of the second circle as 48 centimeters. So the circumference of the first circle is 24, the circumference of the second circle is 48, double. So when we double the length dimension, we would be doubling the circumference as well. Let's look at the area then. Well, to calculate the area of circle 1, we use our formula pi times r squared. We know that the radius here is 4, so we'd have 3 times 4 squared, which would be 3 times 16. 16, 32, 48, which would be 48 centimeters squared. So the area of circle 1 will be 3 times 16, which is 48 centimeters squared. What happens with the area of circle 2 then? Well, the area of circle 2 will be the same formula, pi times the radius 2 squared. Let's keep this radius in terms of 2 times 4. So we have pi multiplied by 2 times 4 all squared. 2 squared, so that this can be rewritten. When you're squaring everything here inside the brackets, we'd have 2 squared, 2 times 2, and 4 squared, 4 times 4. So 2 times 4 is the same as 8 squared. 8 squared is the same as 2 times 4 all squared. These are exactly the same things. We know that 8 squared is 64. 2 squared is 4. 4 squared is 16. 4 16s are 64. So all of these things mean the same thing, but it makes it a little bit easier, because we here have pi times 4 squared multiplied by 2 squared. Pi times 4 squared was exactly the same area we had in circle 1 here. Was this area here. So area 2 is going to be the same as area 1 multiplied by the factor that we had in the diameter, the change factor, which here was just double. But when it comes to area, we have to square, because we're multiplying by pi r squared. So we get a factor 4 here. So we would have the 48 centimeters squared that we would get from pi times 4 squared, multiplied, instead of being multiplied by the factor of 2, because we're squaring the radius in a circle, we have multiplied by factor of 2 squared, which is 4. So we'd get the area here then. 8 fours are 32. 4 fours are 16 plus 3, 9. 192 centimetres squared. So the area of the second circle would be, instead of a factor 2 increase, which we got here in circumference, it would be a factor increase of 2 squared, because we're multiplying the radius by the radius again. So this 2 that we multiplied when we got by the increase the perimeter, we're multiplied by a factor of 2 squared when it comes to area. So you can see the difference here in increasing a dimension by 2 in length actually increases the area dimension by 2 squared.